Charge theory. Charge theory is my theory on what charge is. Definition of charge in physics. Charge in physics is defined as 1. Charge is the fundamental property of forms of matter that exhibit electrostatic attraction or repulsion in the presence of other matter. 2. Charge in physics, symbolized by the letter Q, is also known as electric charge, electrical charge, or electrostatic charge, is a characteristic of a unit of matter that expresses how much it has more or fewer electrons than protons. Electron has negative charge, while proton has positive charge. Nobody really knows the correct understanding of what charge is. This is further shown by an excerpt of an article in Wikipedia. In physics, a charge may refer to one of many different quantities, such as the electric charge in electromagnetism or the color charge in quantum chromodynamics. Charges correspond to the time-invariant generators of a symmetry group, and specifically, to the generators that commute with the Hamiltonian. Charges are often denoted by the letter Q, and so the invariance of the charge corresponds to the vanishing commutator Q, H, equal to 0, where H is the Hamiltonian. Thus, charges are associated with conserved quantum numbers. These are the eigenvalues Q of the generator Q. For an ordinary person, this definition of charge is beyond their understanding. Observe that the charge was defined as an observation, such as attraction and repulsion, the amount of electron in a matter, and even an abstract such as the term color of the quantum chromodynamics. The SI unit of charge is called coulomb, denoted by the capital letter C, expressed in meter kilogram per second unit of electrical charge, which is equal to the quantity of charge transferred in 1 second by a steady current of 1 ampere. From the experiments of the scientists, it was observed that charge appeared only in discrete amounts, that is, it is quantized. In 1909, Robert A. Millikan, an American physicist, first measured the quantum of charge approximately as E equal to 1.602 times 10 to the minus 19 coulomb. The charge denoted by the small letter Q must be an integer of this basic unit, E. The magnitude of charge of electron and proton are the same. For electron, Q sub E is equal to minus E, and for proton, Q sub P is equal to plus E. Brief history of charge. To understand a little bit what charge is, it is important to get a historical perspective on the understanding of charge. Thales, an Ionian Greek philosopher from Miletus in the Asia Minor, present-day Turkey, was known as the first person to have studied electricity. He observed that when amber, which came from a fossilized tree resin, is rubbed with a woolen cloth, the amber would attract small light materials such as lint and feathers. Due to some strange quality of amber, he believed that it contained some unknown force. The Greek word for amber is electron. In 1733, Charles Dufay, a French scientist, published his discovery that there are two kinds of charge, which was then called electrical fluid. He called the one that is produced by a glass as vitreous and the other produced by amber as résineux. Dufay believed that these fluids can be separated by the friction of rubbing. 15 years later, after the discovery of Dufay, Benjamin Franklin, an American scientist and politician, proposed that vitreous and résineux were not actually the different kinds of electrical fluid, rather in the process of rubbing, a single fluid flows from one body to the other. He coined the term positive for the vitreous and the negative for résineux. He designated the body that gained the fluid as positively charged, while the other one that lost the fluid as negatively charged. In physics, the term spin, which is supposed to be referring to the spin of a particle on its axis, is not considered as an actual mechanical spin of a particle, rather it is one of the quantum numbers specifying the states of the electron. In fact, we can see from the Standard Model that spin has a value of 1/2, where if we are talking about an actual mechanical spin of a particle or a body, it is either it is spinning in a clockwise or counterclockwise direction or not spinning at all. We can see in the Standard Model that charge and spin are distinct property of a particle. Also, just as spin has a value in fraction, charge also has a value in fraction. The discussion of spin in physics is a much deeper discussion, which when delved with shows the errors in the current physics. If my memory serves me, I came about with my understanding of what charge is when I was thinking of the attraction and repulsion of the materials. I imagine two gears rotating in the same direction, that is, they have the same charge, and the other was two gears rotating in different directions. The two gears rotating in the same direction will not mesh and thus will bump with each other and go the opposite way. The two gears rotating in different directions will mesh with each other and will rotate in couple. The same thing could be thought of for the whirlpool and the spinning top toy. My charge theory states that charge and spin are the same. Positive charge particle spins in a counterclockwise direction, while negative charge particle spins in a clockwise direction. Neutral particle do not spin and neutron's field do not spin even as the quarks inside it are spinning. How did I determine the direction of the spin of the negative charge particle? Having a background in electricity, I remembered the right-hand rule. The right-hand rule is used to determine the direction of the electromagnetic field around a wire, knowing the direction of the current. This is done by holding the wire with the right hand. The thumb points to the direction of the current, while the direction of the fingers shows the direction of the electromagnetic field around the wire. Note that looking towards the current, the electron may be spinning in a counterclockwise direction. Comparing later with the result of the bubble chamber experiments, I noticed that the negative charge particle spins in a clockwise direction. This discrepancy could be explained because the direction of the current is called a conventional current, which is actually opposite of the actual flow of the electrons. By using the left hand, when applied to the conductor used in the right-hand rule with the direction of the field is maintained, the left thumb now points downward. Turning the left hand up with the thumb pointing up as the direction of the flow of electron, looking from the top or facing the electron, the field is spinning in the clockwise direction. In my video on gravity, Descartes and Newton do not know why is a planet orbiting the Sun or why is the Moon orbiting the Earth. This is the answer to that question. In my quark theory, the up quark makes the down quark orbit it. The up quark is a positive charge particle, which spins in a counterclockwise direction. The down quark is a negative charge particle, which spins in a clockwise direction. In my new model of an atom, the proton makes the electron orbit it. The spin of the up quark is translated to the proton. Thus, I had forwarded that the counterclockwise spin of the up quark was also translated to the proton, star, planet, and moon. The proof of the understanding of charge as spin had been there all along that can be seen in the bubble chamber, cloud chamber, and modern detector, which corroborates my theory. In the figure shown, we can see that the positive charge particles are curving in the counterclockwise direction, while the negative charge particles are curving in the clockwise direction. We can also see from the image the electron-positron pair denoted by the E- and E+. In this famous bubble chamber image of the electron-positron pair, we can clearly see that the curl as it was described in the book shows that the positron is curling in the counterclockwise direction, while the electron is curling in the clockwise direction. Note that as charge is still not understood today as the spin or the direction of the spin of a particle, physicists and science writers do not correlate charge and spin as the same, and in fact a charged particle is identified by the direction of its curving behavior. Charge theory. In my charge theory, spin and charge are the same. That is, the direction of the spin is the charge of the particle. Looking from the top or facing the particle, positive charge spins in a counterclockwise direction. Negative charge spins in a clockwise direction. Neutral charge particle do not spin. Neutrino particle do not spin. In the neutron subatomic particle, only the energy field do not spin, while the quarks inside it spins. My charge theory explains the observed attraction and repulsion. Other matters relating to charge are just the properties, behavior, mechanism, or value of charge. Since my quark theory overthrows quantum chromodynamics, this means that my charge theory do not recognize the color charge. I challenge all the brilliant people, science and physics teachers and professors, scientists, and physicists to prove if my charge theory is right, since it affects our understanding of what charge is and the various theories that includes it.
Please give proper credit to the author for discussion of his ideas and theories. Thank you.